All right, so this is going to be like my best practices for doing MicroPython development with the ESP. Well, actually, with anything with MicroPython, but I'm using an ESP8266. It'll work for the ESP32. It'll work for the Pi boards. It'll work for any of that. But basically, if you look at the way that you're connected to the board, you end up with this kind of batchy process, right? What you don't have is you don't have the ability to run a remote editor on the board in remote execution. So in this case, what we've got is we've got a developer machine. We're talking about the stuff in yellow. We have a developer machine. We've got a USB to 3.3 volt adapter, serial adapter, and then that's plugged into the IoT board, the development board, or the board under test, whatever you want to call it, right? And what that means is we're going to do the work on the developer machine, and then somehow we'd like to communicate over the serial adapter, get files out there, and get and be able to run commands and that kind of thing. Now, it turns out MicroPython's great for this. It actually supports the ability to transfer files onto a virtual disk on the device itself, the /PyBoard drive. And you can rename that if you rename your machine. But the other thing it lets you do is open a REPL or REPL. It lets you open the Python shell and you can practice with it. So what we're going to do is we're going to make use of that in a mixed mode where we're going to create modular files. Let me see if I put that here. Right. So what we're going to do is we're going to create Python code in functions and in classes. And we're going to get these really pretty small. We're really space constrained on this device, so I'm not, you got to be cautious with a little bit. But we're really not going for speed of code per se, or, if we were super tight, we would end up writing the code, in C or something else. But the idea is we're going to burn a little space so that we can have a better developer experience and so that we can debug. So what we're going to do is we create Python code in functions and classes. You're not going to create a giant main.py and then just jam everything in it, because then you got to upload this big file every time. And it means you can't test. We want the ability to write testable code outside of running the whole thing. So what we do in my case is I also put the main loop in a function like main, open paren, and that lets me actually run the main. And then I can control, in the REPL, I can run it, right? Whereas if I just have a giant function, it's just like not as good. So the idea in the REPL is we should be able to load, import, and then run the different classes and functions, and including the main. And then the next thing we're going to do is we're going to dependency inject as much as we can in the class configuration. So in my case, I typically do classes. And when I new up the class, when I instantiate the class, I actually pass in all the parameters so that it's customizable rather than having it reach out. Because that way, all I really need to do to test something is new it up and then run a method in it. New it up and run a method in it. And then the other thing I'll do is I'll put configuration constants, pull all the configuration, that's wrong. I should say pull all the configuration constants out of the modules and into the config file. And that lets me reuse that config across multiple modules if I need to. And I just push it once for that machine. And because, I wanted to do these functions and classes, right? Not just one big, I don't want just, beginning to end of a file, just nothing but script code. I want to make it easy to run those functions in the REPL. So really, we're going to change the shape of our code to be testable and runnable in the run loop, right? The run program loop. All right, so I have this Git repo you can look at out there. So let me just give you an example of this, right? So in this case, I have a method called toggle pin, and I could have written this thing where it reached out to variables and knew what pin automatically you were going to do, and all of that kind of stuff. But to my mind, that makes it kind of hard to test in a couple situations. And what I wanted, I have a board with a couple different LEDs on it, and I wanted to be able to test that those LEDs were working the way I want, and I do that with def toggle pin, right? With this function toggle pin, and it takes the pin number and the milliseconds and how many times we want to blink it. So this is really blink a pin, right? It will flip a pin back and forth however many times you tell it, whichever pin you tell it, and then and then it'll wait a certain amount in between, right? So when I want to test that, all I do is import toggle from toggle pin. if I make this bigger, is that going to help? Yeah. Import toggle. So here you can see all I'm going to do is import that toggle function, and then I can test it, right? And so I can just push an update to that file as often as I want, or I could paste that file in as a function, and then I could test it. But the idea is to run something from the command prompt, from the Python prompt. I really want it to be totally parameterized if possible and be a function. So I'm going to show you another one here. This one makes an HTTP call to a URL, and it just prints the output. I took this from somebody else's code and renamed it, made a couple changes with it. But the idea is you give it a URL, it'll do a GET call, it'll take and it tries to protect itself from buffer overrun. That's why I like this one. And it just prints it. And yeah, because we can't do anything else. We can't return a giant buffer maybe. We don't know how big. We don't want, like a buffer overrun thing. And then to test it, all I do is I import this from the HTTP GET module. I import HTTP GET print, and then I just call it. So that let me just push that file and then call it. Push the file and call it. Push the file and call it. The other thing I can do is I can paste that file in and call it. For some things that works better, but what I said was a file would have a few different related functions or a class or a single function in it, and then we just test it from the command line, right? And then what I did also, so like if you look at the main, a lot of times the mains are really giant. I don't like that, and the reason is if there's anything wrong in there, it's harder for me to debug with this long cycle. So in my case, I put everything in a function or everything in a file, everything in a class. And then, so this one here is actually pretty powerful. This actually runs a web server. What it does is it goes out to the Wi-Fi and connects it, right? And this is how I tested my Wi-Fi code to make sure it worked. I would just, if you pop in and out of the out of the command prompt, whenever you come back in, you're in a new shell, right? It'll actually reset it. So I could pop in, upload a file, pop in, run it, pop out, push the file, pop in, run it. And so I get that kind of debug loop. And because there's no compile, it's actually faster than troubleshooting and doing it some ways you do on some of the IDEs, right? It's not like this board is big enough to have a remote debugger connection. So here, we actually import a couple files. We have one to set up the Wi-Fi, right? And then it runs the Wi-Fi. We have one to just go out and get a test URL from the MicroPython org. And then I toggle the blinky lights to tell you that, hey, we actually have a Wi-Fi connection and we actually went and got a file. And then I bring up a web server, and that web server's actually got 2 pins. It's going to use pin 2 and pin 16. It's going to put up in the UI, and then it runs the server. Boom, done. And on restart, it's going to call this main piece down here. It's going to look, and it's going to call this main function. So I have a main function I can test without having to copy and paste it every time. I can just pop the file up. It's actually a lot cleaner in a lot of cases than copying and pasting that code over and over and popping in and out. So this lets me play with that. And then I have it set up so that it'll boot on a main.py, just like you would expect in MicroPython. So I don't think, like I said, for me, it's put your configuration in its own file so that it can be used across modules. Organize your code into functions and classes. Write the functions and classes so that they're easy to run in REPL. So be smart. Think about how much code you want to type or paste. Make your functions work for that. People always get mad because like testing changes the shape of their code, but that's actually ideal. And we're going to organize the code so that the main.py has as few lines of code in it as possible. That thing should not be a monster. Unless you've got like some super performance characteristics that you have to make as few function calls as possible and put as little on the stack. So we don't want it really deep. In my case, it's normally too deep. The main and a bunch of utility classes that it calls. And then we configure startup to call the function main in main.py. Right? So like I said, this is the work loop. Now, I tend to use R shell to do all this, to push code by copy and also to open the REPL. I love R shell. I'm like super impressed. So what do? We edit the code in the IDE. We upload a module to /pyboard using R shell. We drop into the R shell REPL, right? I'm going to get banged for how I pronounce that. We run any initialization code that's required, like bringing up the network. In my case, that's 2 lines. Import, run. Oh no, it's import, create the connection, connect. So it's actually 3 lines of code to bring up the network. Then we run the module standalone to verify. So I will always usually bring up the network or whatever other config is required, and then I'll verify that function. When that looks like it's, when I have some issue with that, or I want to stop something from running like the web server, I will hit Control C. That'll stop whatever is running. I'll be back into the prompt, and then I'll drop out of the prompt with Control X, because that puts me back into R shell. And then I'm in the IDE Visual Code writing stuff, and then I'll use R shell to copy the code back out again. So we basically repeat this for every module. We go through this kind of tight loop. And then I work on the main.py, which is the main loop, to call these modules as I add them. And that's it. There's another thing here a little bit, which you can't read, is how to get the variables set up right to get R shell on a Windows box. And that's it. And I have a project out there that I've been using for testing. It's got like 6 files in it. You can copy them out. And I hope that will be something useful to you. Did I want to show this? I could. But you know what? I'm going to do that in another video because I'm already at time.